formula is the lowest ratio of elements, whole number ratios of elements in a compound. When given a percent, like in this problem, the rocket fuel contains 87.4% nitrogen and 12.4% hydrogen, we actually assume that we have 100 grams so that we can make the 87.4 actual grams. So we're just going to change the percent sign and we're just going to put a G. So no calculations or anything, just percent becomes a G. So that's our given. 87.4 grams of nitrogen. Don't worry about diatomics here. No empirical formula do we worry about diatomics. And 12.4 grams of hydrogen. So then the next step is to look at the molar mass of those elements. So I know nitrogen is 14, again, not diatomic, and hydrogen is 1. And so then I convert those to moles. Well, we know really simple that the molar mass, we take the grams that we're given divided by the molar mass. And so if you do the chart the way that I'm doing it, we take our given, we write down the molar mass, and then you divide. And so when I divide these out, I end up with 6.24 moles of the nitrogen, and I end up with, well, that's easy to divide, 12.4 moles of hydrogen. So then, the next step, the one that people seem to forget a lot, is that divide by the smallest mole. So I have to choose 6.24 or 12.4. Well, obviously, 6.24 is smaller than 12.4. So I divide both of them by the 6.24, and that gives me my mole ratio, which comes out to be 1 and 2. So then I need to look, does either one, and make sure that when you divide these out, that you do not round too much. And so if it ends up being like a 0.00 or a 0.99, then you can round it. But if it's a 0.5, you need to leave it, and then we would just multiply everything by 2. But in this case, I don't need to do that. And so all my empirical formula is I now take that subscript, well, I don't write a 1, and then I have hydrogen with a 2, and that is my empirical formula. So the empirical formula is the lowest whole number ratio, but it may be some multiple of that for the actual formula, in this case, rocket fuel. And so what we do is we look for the molar mass of the molecular formula, and the problem gave that to me right here. It says the molar mass of the molecule is 32.05 grams. So I'm going to write that down right here for the molar mass of the molecular formula. They have to give you that, or you won't be doing this next step. And then I have to then calculate the molar mass of the empirical formula. Well, that's pretty easy. I know that nitrogen is 14. I know that hydrogen, I have 2 of them, 2 times 1. And so I know that that's 16. So then if I take that molar mass of the empirical formula, which is 16, notice it's just set up nice, that this is equal to 2. So then, to figure out my molecular formula, I take my empirical formula, which is N2H2, and then I'm going to take that 2, and I'm going to multiply by each one of those subscripts. So I'm going to end up with N2, and then 2 times 2 is 4, H4. So that's my molecular formula. So this is my molecular formula, and this is my empirical formula. And that's how we work these problems. Pretty basic and simple. Now, I want to go ahead and work one that does not come out even. And I also noticed that in this particular problem, I did not give you percents. I actually gave you grams. And so grams just saves us a step. We don't have to change our percents to a gram. We can just write it down. So what am I given? I'm given 4.38 grams of carbon. I'm given 0.314 grams of hydrogen. And I'm given 1.66 grams of oxygen. And so again, we're going to go look up the molar mass of the elements. And so I go to the periodic table, and I know that carbon is 12 grams, hydrogen is 1 gram, and oxygen is 16 grams. Just the single element is all you write down. So then I'm going to convert these to moles. So just, again, by adding that little line, it tells me to divide. So I take the grams, I divide by 12, and that gives me 0.365 moles of carbon. This one's always simple. I always like to do the hydrogen, so you just divide by 1. And then the oxygen, the 1.66 divided by the 16 comes out to be, and you're going to notice that I'm going to write a lot of numbers down because it's not good to round too much on these or your next step won't come out right. So which one of these guys is the smallest? So I need to divide by the smallest. Well, that's my oxygen. So I'm going to divide all three of the numbers by oxygen's number. So then when I get my answer, that's going to give you my mole ratio. Well, it works out that this one actually comes out to be 3.5. Remember how I told you not to round too much? This one over here comes out to be 3 for hydrogen, and then obviously the oxygens are the 1. So now that's my next step. Multiply by 2 if one of them ends up to be a 0.5. So I'm going to have to go through and multiply, but don't forget to do this. You're multiplying everybody by 2 because I got to keep the same ratio. I can't just multiply the one with the 0.5 by 2. I have to keep the thing the same. So they're still really the same thing if I multiply them all by the same number. So then that gives me the numbers, the 7, the 6, the 2. So I go back up. So my final answer is that carbon has a 7 on it, hydrogen has a 6 on it, and oxygen has a 2 on it. So that's how you do an empirical formula that ends up having a number that you need to multiply by 2 when it doesn't come out even.